Hello and welcome to today's SKILup session from DevOps Institute and PeopleCert, powered by Techstrong. I'm your host, Manuel Schuller, and today we are talking about container orchestration that comes to serverless computing. So on our panel today, we have Leonardo Murillo, Melissa Sussman, and Vyacheslav Matsukevich. Before we get started, I want to let the audience know that this program is live, being recorded, so you can view it again for on demand. Also, there's a chat and QA box on the right side of your screen to communicate with the general audience in chat, questions for the speakers, so don't hesitate to use it. There is already the chat with the welcome from Cody from PeopleCert. So let's start with some introductions. If you want to introduce yourselves very briefly, Leonardo, will you start?
All right, sure. Thank you all, and then thanks everybody for being here today. It's great. December almost over, so everybody's looking for an opportunity to not work and learn new stuff. So that's fantastic. All right, so my name is Leonardo Murillo. I'm founder and CEO of a consulting company called Cloud Native Architects. I'm also a DevOps Institute ambassador and advisor to the Dev Network Advisory Board for Latin America. I've been in the industry for a long time, and I'd love to be here and share some knowledge with you. So I'm going to pass it over to Melissa.
Hi, everybody. I'm Melissa Sussman. I work at Sumo Logic as lead technical advocate. I guess my general background, you can read what it is, but basically I have about more than a dozen years of experience now working as an engineer, working as a product manager, and at different times of my career. And now I'm doing more stuff, something that aligns more with, like, I guess, dev advocacy and technology advocacy, technical marketing. Vyacheslav?
Okay. Hello, everyone. My name is Vyacheslav Matsukevich. So I am an infrastructure engineer at a startup Hino. So I have over a decade of experience in different roles, like system administrator before cloud, cloud architect, solution architect, DevOps, system engineer, different names, sometimes about the same stuff, about different stuff. Lots of experience in consulting, in system design, that kind of stuff. And I'm looking forward to learn something new and share something interesting in this event.
Okay, excellent. Thank you very much, all of you. To set up the scene, I'd like to start with a very simple question. Maybe which is more of a definition, because probably some attendees are new to the topic. What does serverless mean to you today? Who wants to start? Melissa?
Ooh, I got picked on first. Interesting. We're going to mix things up. So to me, it basically means, so I originally came out of this, I guess, from the hardware world, and then I ended up eventually working on cloud stuff. To me, the word that it screams is like, the idea that you don't actually have to run things on physical hardware yourself. I mean, you could like maybe borrow someone else's, like use AWS services or whatever. But that the infrastructure itself that you're running on is not something that you're running yourself all the way from like the bare metal. To me, that's what it means.
Leonardo?
Yeah.
All right, I'll go next. So yeah, I think serverless is first of all is a misnomer, right? Because there's always going to be servers somewhere, and to me, serverless has evolved over time, right? When the cloud just came out, right? Serverless meant VMs. You were not actually running, as Melissa points out, right? You were not running the underlying hardware, and now you had this virtualization layer on top of it. But it has evolved over time, right? As functions as a service came about, and then as specific services became abstracted away in everything, databases, like now you can basically get everything managed for you. So to me, serverless means abstraction, right? Abstraction away from complexity. whether it is the complexity of operating a physical piece of machinery, or the complexity of managing a VM, or the complexity of managing storage. As the further away you are from that underlying infrastructure, the more serverless you become, or the more serverless starts to exist, right? And I think it means different things to different people, right? Managed services, functions as a service, even containers are to a certain degree serverless, right? So I think that's also why it's very relevant to have this type of discussion, right? To make sure that people are coming to a common understanding of what serverless means for their organization and within their architecture, right? Well, what do you think, Vyacheslav?
Yeah, I completely agree with you on that. So I think it really depends on how people are using it, and then through what lens they're looking into it, right? So like, who is it? Is it infrastructure engineer, or is it like developer? So who is actually setting it up, or who is consuming it? So yeah, it can be like a container running on demand, or just a simple function running somewhere. And yeah, I think. That's you covered really deeply definition of it. I completely agree. Nothing to add, to be honest.
I think you're muted, Manuel.
Thank you, Leonardo. Sorry. There is a comment that I like that came up at the very beginning of the discussion, which is serverless is something you don't want to manage. Oh, it's a kind of yes, sense of humor of the participant, but yeah, this is roughly what you all explained. Okay, something a level of abstraction where the server itself is not anymore something important.
Yeah. And just to kind of like riff off of that, I think it's relevant component of the conversation to realize that what's really happening is that what you're managing is moving up the stack. I don't think you ever get to a point where you're not managing your technology, right? It's where your focus and where your effort is migrated into, right? So it's not something you don't want to manage, is where you want to focus your management energy onto, right?
Where you want to add the value.
Exactly.
Okay. And talking about value, what do you like, all of you, in the that serverless architecture? What are the benefits? Vyacheslav?
Yep.
Do you want to?
Yeah, I think a level of abstraction, right? As Manuel said, it's really good. I mean, now it's much easier for a developer to start running application, running code somewhere. You don't need to know much. You just need to know where to put your function, and it will be there running for you, doing some business logic. And it's really simple. Much less skills required, I think, to just get started at least. Right? It also, yeah, I think there are some use cases where just serverless is just a perfect tool to use for some asynchronous workload where you don't want to pay in advance. You're just paying for what you're actually using for just how long your code is running. So I think this is a main benefits, and it's easy to get started nowadays with a new application. Just using this functions. And also I like that it used to be idea that serverless is you need to pay something extra for someone else doing for you, but now you can also run it yourself, right? You can install such software on top of your servers, right, and build an in-house serverless solution. And manage everything underneath, so and customize it as you want. So I think these are the main things I like about serverless. Melissa, what do you think?
So I guess I've been on like both the vendor side of this thing and then also the consumer side of this question. By that I mean like this is all business to business stuff. So I worked on like years ago. I worked on in the hardware world on a compiler that was like something people were still using in desktop development, and then we had to like move everything to the cloud. There was the like Cordis suite is what we had. We moved it to the cloud, and then like basically desktop development started to die. And it was a bittersweet time for me because I really like desktop development. I still do things in desktop development, but I think there were a lot of things in the world that kind of necessitated that, a lot of benefits to going to serverless, obviously. For us, it definitely was like, oh, it's more scalable. You get, people can access the compiler more easily. People can access the developer tools more easily. This was like for developing on FPGAs. You can actually like scale up and down in universities. There's like, a lot of people who don't know how to program in VHDL. So having like something that people could program in C++ or whatever. And the idea was, hey, we could like take this thing to universities and, anybody can just kind of like get a software license. And we didn't care too much about, we sort of cared about software license costs, but like we cared mostly about the cost of people actually, like the energy and the time that it takes to actually learn how to code in hardware. And then I also worked for a while on sort of the other side as like a vendor, doing like, right now I'm in an observability product. So, obviously like there was this big effort to do digital transformation and stuff like that. So we also have customers that now benefit from that. Like Ulta Beauty we have a case study that's really good that goes into like the transformative impact of cloud migration and how it made things so much easier for them. Basically being able to leverage microservices and modern application strategies in addition to running everything serverless, because it basically made for a more like efficient, reliable, and secure like digital e-commerce site. And so there's all those really great benefits.
Yeah,
Yeah.
yeah, definitely. So I think there's this term that AWS uses a lot, which is undifferentiated heavy lifting. And I think a serverless, I guess the one thing that I would highlight as its primary value is that it eliminates the effort associated to that undifferentiated heavy lifting. And I think that the component of undifferentiated is that it doesn't provide any strategic value to an organization specifically. What I mean with that is every organization needs to go through that process, right? And as cloud architectures become more complex, concerns around scalability, concerns around security, concerns around best practices and observability. These are all things that everybody's going to have to focus on, right? And that they're just complex, they're time-consuming, and they distract very creative folks from actually building stuff that could provide a lot of value, right? So to me, abstracting away that undifferentiated heavy lifting, that undifferentiated effort, is one of the more relevant components. And by removing that and abstracting the interface to access those capabilities, right? I think they're empowering. They empower developers and they empower different technical stakeholders to be able to build without having to have kind of this latency from idea to deployment, right? Which I guess it's kind of like this whole idea of faster time to market, right? So yeah, I think those are the highlights that I would point to if I were to think about value prop of serverless.
We got an interesting question, and I hopefully can answer it quickly without going off into like the nether sphere of talking about hardware. The answer to that, so someone asked, have I seen software no, they're not software devs, they're hardware devs. So first he says, they say like, what did you say, let folks program in C++ instead of VHDL? Sounds very dangerous. Have seen the results in real life, have to understand inherent concurrency of hardware before being set loose to write good synthesizable VHDL. So the way that it works is like people write like golden top reference designs, and then that gets like put into, and I used to actually do like marketing engineering for like a design store that had like open source hardware. So you would essentially use like the golden top reference designs. Yeah, it is very different with hardware. So then basically like that's the pinout designs, and that's like the designs of like the I guess the dev kits themselves. I think actually I have an old dev kit in the corner back there I can show you, but like basically it connects like all the different, protocols and connectors and all this other stuff. So like somebody's out there actually writing the code for the protocols and for all of this random stuff that's connecting to the dev kit. and for the dev kit itself, and someone's designing it. And then basically like you use that as a reference design, and then you can actually build stuff on top of that. And HLS is a lot like HLSL. So for GPUs, you would do for HLSL, you'd be creating compute shaders. And then for like FPGAs with HLS, you'd be essentially creating some equivalent for an FPGA that then can become an ASIC. And yeah, anyway, the serverless is great because actually like people don't have to do all of that all the way from scratch anymore. So when I worked at Xilinx, we did a SaaS deployment to AWS. So AWS actually buys the hardware, like they actually purchase, and then you can rent from AWS with Amazon machine instances. And hardware developers don't have to really, I mean, you don't have to actually be a hardware developer these days. You can just take like a bit stream that's been pre-written by the community or by like someone that probably works at NVIDIA or Xilinx or whatever. And then you can run like AI and machine learning workloads on that hardware through an Amazon machine instance. It's great because then like it actually makes it really accessible to people who are not familiar with hardware. And then they just do software and they don't have to do all of this like on-premise management and like design work that's probably done by someone else somewhere else and might just be open source now anyway.
And you know what? Some that came out that just came up that I think it's valuable to highlight. And just before we wrap up this topic is you mentioned something, Melissa, that I found very interesting. The looking at serverless from the provider perspective, right? Not just from the consumer, but I think like if anybody in the audience like is in a SaaS company or building some sort of like as a service product, I think from the seller perspective, from the provider perspective, building something that can be scaled, that you control, that ensures that your users are following best practices, and that you reduce the diversity of ways in which people can actually build stuff and provide them something that is opinionated according to something that you trust, is also something very valuable of serverless from the seller perspective, right? Like, you know that if you're going to use a service that is managed by some cloud provider, you have a certain level of trust that their opinions that are baked into that offering are following practices and references that are going to be resilient, that are going to be scalable, right? And from a seller perspective, ensuring that all your clients that are your users are working on top of that platform, I think helps you guarantee a good developer experience, a good user experience, and kind of like resilient architecture downstream.
The thing I love in the SKILup sessions is that we are able to have serverless architecture as the main topic and some breakout conversations on FPGA hardware.
Well, it is possible to do serverless stuff on hardware. It's actually so like people do actually deploy like bare metal designs with Kubernetes and stuff these days. Like it is a thing that people do now on AWS environments. And so I mean, people do it. I mean, it is applicable. And there's a lot of stuff that we don't even think about that's being run based on that. I mean, every time you turn on your computer, somebody wrote that compute shader for your GPU or whatever. So it's like it's hard to think about too much, but because then it'll make your brain explode. But yeah, I mean, I didn't mean to divert the topic too much anyway. It relates back to serverless because we actually enabled people to be able to just upload bit streams and not have to write everything themselves. So that then they can do something cool like create a video game or whatever you do with software.
So what I noticed is that we started 18 minutes ago, and I just heard from you, Melissa, Kubernetes. It was not before. I mean, I was expecting after 1 minute, 2 minutes, but 18 minutes. So for you, what is the link today between serverless, which is a concept, and Kubernetes, which is more than a concept, technology? Is the link very strong? Is the link that strong?
For me, yes, because, well, I mean, it's like the biggest open source container orchestration and management platform. And it's basically, I guess Google, I think had done some significant contributions and everything, but like over the years, it's just been the de facto standard, it seems, for like everybody has some Kubernetes equivalent, AKS, EKS. Every cloud vendor has something too. And like it just makes it easier to do things like deploy and and everything without having to actually like manage everything on-prem. So it does help, obviously, and it is the backbone of a bunch of different cloud service providers. I don't work at a cloud service provider. Someone else can do an opinion on that.
I think with Kubernetes, nowadays de facto becoming new servers, right? In that sense, in the relation to serverless, right? So as Melissa mentioned, like a backend for lots of stuff. So I bet cloud providers, running functions based on Kubernetes on the backend, something like that. But in general, yes, you can even find open source software available to you that you can serverless, like a function type software that you can install on Kubernetes and customize it all the way you want and make your own opinionated functions, right, or something like that, and run it yourself. And this is a connection between Kubernetes and serverless. It allows you to build serverless yourself, for example, right? And I think it's the main alternative nowadays. If you want a bit more control, you don't want serverless, like the ones that managed by someone else. You usually go with Kubernetes as a go-to solution. So it's just a main competitor to the serverless as well. Yeah, Leonardo, what do you think?
I think so. Here's what I think. First of all, I think Kubernetes is a great example of abstracting the complexity of the infrastructure away. And basically what Kubernetes is doing as an orchestrator is it's abstracting away the complexity of identifying which server to run your stuff onto, right? Like whenever you take a container image and you want to run it somewhere, it's actually going to run on some node. It's going to run on some server, but Kubernetes is abstracting that away, kind of like building in all that complexity and everything that revolves around it, right? Like how to move it around, how to fail it over, how to provide a declarative way to define your storage and your network, right? So I think Kubernetes is a good example of how you can abstract away complexity of managing workloads and the runtime and the deployment, right? But even with Kubernetes, there's been the same evolution that I've seen over time in reduction of complexity. And I think cloud providers, so Melissa pointed this out, cloud providers have seen that. Because provisioning a Kubernetes cluster when you actually had to do it on-prem on a set of machines wasn't trivial. Managing that cluster, upgrading Kubernetes as a control plane wasn't a trivial exercise. And again, undifferentiated heavy lifting. And as cloud provider has seen that, they've also increased the level of abstraction to what Kubernetes means in terms of serverless. You got like Google's autopilot for GKE, right? That handles the full life cycle of your nodes. You got Fargate, which is like from AWS, which is even further out, right? Fargate is crazy. You get like a VM per pod, which is insane, right? And there's this level of full automation and abstraction. And the good thing, and this could be a good segue to a different conversation, is how Kubernetes and the different capabilities that are being built in as a serverless piece of machinery to your technology estate, right? Provided kind of like this layer of cloud agnosticity to the way that you approach serverless architectures, right? Because if you look at serverless from the point of view of, say, functions as a service, and you look at either Lambda or whatever else they have, different cloud providers, you always worry about like the whole idea of vendor lock. Am I building something that is only going to be able to run at this particular cloud provider? But with Kubernetes, whether you're using Fargate or you're using Autopilot or you have kind of like your homegrown Kubernetes running on-prem, with some caveats, of course, you have a lot of flexibility in where you deploy your workloads and how you move them around, and you have kind of like this consistent control plane layer across your different potential deployments. So yeah, I think in a nutshell, I think there's a lot that Kubernetes can teach us as to how to approach serverless. and a lot of the cloud providers have learned as to how further abstract away Kubernetes' complexity, and it does serve as a layer that gives us portability to our workloads.
Okay, so thank you to all of you. I would like to go into the usual stuff about technology or about the concept, the benefits, okay, against the challenges, especially that serverless is now a concept that has a certain level of maturity. What I mean is that I meet a lot of big corporations or big companies that have gone or that are going serverless. So at scale, what would you mention in your experience in terms of challenges and in terms of benefits, obviously? Wants to start? Melissa?
All right, I guess I'll start. So I guess I can list out a few different challenges that we experienced with moving everything onto. So there's like in the hardware world, you're moving things onto AWS, and then there's all these interesting workloads that people can run. And no, you're not having the software people write those workloads, but like you'd know AWS would have their AMI, and then you can basically run like the Vivado suite or whatever within the AMI. Or you can like, let's say, move the bit stream that, let's say, does some color detection or like edge detection or does like some amount of like analysis on images over to like a specific FPGA that's like sitting, or like GPU or whatever that's sitting in the that AWS basically manages. On one hand, the migration of that, it did present a lot of challenges from the vendor side, because you're like, as the hardware vendor, you're not selling the hardware anymore. You're essentially like renting it out, and you don't make as much money on that over time. AWS makes most of the money. But the cool thing about it, like the cool thing is for the end user, because then the end user doesn't have to like know all of this esoteric stuff on how to like manage or upload the bit streams or do all of that. They can just it'll just work. They can just go in there and just be like, I want to do something cool with machine learning, but someone else already wrote it, and I can just kind of run this and test some things out. Or you can have like universities, like I was saying before. I mean, we think a lot about enterprise, but you have to also consider like universities, because that's the next generation. And and the ability to scale up and down, and then the ability to also teach, it helps in the future, because then eventually you're going to have people go out and actually like buy this stuff in the next 5, 10, 15, 20 years. And the number of people who actually still know how to do hardware design, it has been decreasing in the US, like proportionate to the number of people that live in the US. So it's also just, I think, like really good for that perspective. But you do have to think about other things too. Like if you're running your own infrastructure, and there's like a disaster or like something bad happens, then disaster recovery becomes an issue. If it's all serverless, then you have the ability to have it backed up by somewhere else. There's a lot of just continuance issues that can happen, especially like with payment portals and that sort of thing. So a lot of things to consider. Leonardo?
All right, so am I audible? Well, my screen froze there for a second. Is my internet good?
Yeah, you are.
Yeah?
You are.
All right, cool. All right. So I think some of the challenges that I've seen in adopting this type of architecture, one is the kind of like the dramatic change of mindset, particularly for operational folks, right? People are very used to like having to going into servers, like particularly at kind of like if you're coming from an enterprise that is migrating from kind of on-prem, right? Building an architecture that is friendly to the serverless paradigm is a whole different ballgame than just migrating what you had on-prem, for example, or building things the way that you had built them in the past. And this is funny because I've actually had clients that they come to me with architectures that actually have hard-coded IP addresses for their different services. And I'm like, well, you need to start thinking differently, right? So that's one thing. The other is faster time to market and developer velocity is a kind of like two-sided sword that has to be effectively managed, particularly at large organizations, right? When there is a high interdependency, there's services consume one another in very complex ways. If there isn't kind of like an overarching enterprise architecture, the architectural vision driving how all these different teams are building their stuff, and there aren't proper practices in terms of versioning of kind of like API first design and versioning those interfaces. What could be just a complex architecture becomes a complicated architecture, and that is very difficult to manage over time. And I think there's also a challenge in terms of complexity when things go wrong. Like, I think serverless is phenomenal when things are fine, when things are all operating as you expect and as you anticipate. But sometimes, and this is particularly relevant for organizations that kind of have already production level serverless deployments, whatever serverless means for them, because of this level of abstraction, when things go wrong and you have to go into this dark holes of knowledge, kind of like rabbit holes of debugging, things can get tricky and complicated. So I guess one challenge is I think you shouldn't take management, and I said it before, I don't think you should take it for granted, right? I don't think you should, like, if you're an SRE or if you're a DevOps or infrastructure engineer, you really cannot just kind of like out of sight, out of mind. There's always going to be a component of observability. Things will go wrong, even in serverless worlds, right? So being prepared for handling that type of instance of issue is very relevant. Those are common challenges. I think that a proper solid vision as to how serverless is going to be used in the organization, and enterprise level architecture overseeing and leading and guiding that process helps a lot in ensuring that that type of setback doesn't happen, that roadblock doesn't happen, and making sure that your operations and SREs and everybody else is well prepared and given the proper tools, the proper knowledge, the proper time to adjust to kind of like this new paradigm of how things are done. What do you think, Vyacheslav?
Yeah, I agree with all you just mentioned. Just want to highlight that I think overall main challenges are tied to challenges of digital transformation in general. Like going to a cloud, it's all together. Like the way you build things now different, and then it's another piece of different architecture, that kind of stuff. And then different organizations, especially large one, are doing it in a different way. So some of them, just opening up cloud for developers, and then it's Wild West. Everybody's trying to do whatever they could, like new capabilities. It's cool, it's good for time to market, but then there is no just general enterprise architectures, that kind of stuff. And then maybe for the people who got like further away with like the most sophisticated cool setups, they just spreading the knowledge across the organization, and it's becoming like a pattern, right? Like a framework for everyone else to adopt and adjust. Or other way around, they just open up like one service at a time, just building like maybe common architecture, follow this pattern, so it will be easier to manage later on, that kind of stuff, but which sometimes a bit behind because nowadays cloud providers releasing new services almost daily, and to be on top with new features, new capabilities. You just cannot really produce that much of a standard architecture. It can be changed tomorrow, so you constantly need to manage that. So it's like a trade-off for bigger organization today, like how they want to do that. Yeah, I think this is the main challenge. But new organization, right, like startups who the startups, it just comes natural to them. They have access. They don't have such limitations. They just using whatever it works. And I don't see like a lot of challenges for small organizations who is just starting, who is ramping up. It's just a great tool for them, really cost effective, really scalable. And yeah, just doing exactly, and they're getting most of the values, I guess, from this one. Yeah, something like that.
Okay, and to go on with what you were saying, is there something like an adoption cost for serverless for companies?
Yes.
and and what do they have to expect?
Okay, so I mean, yes, I think if I recall correctly, I don't remember like how many hours it took or anything for different companies to do their digital migration stuff, but I've worked with a few different companies that have done that. I know like so for right now I work at Sumo, so we do like observability stuff. So I mean like moving people to not just public clouds but even like multiple clouds and then it is tough. But like I think the cost is basically they're going to have to hire people who know how to do very specific new skills like load balancing. They're going to have to hire people who know how to actually, there's this really great thing, the modern application reference architecture from Nginx. I'm such a fan of Nginx that a lot of people can use to at least like start their migration and kind of get an idea of, well, what do modern apps look like? Like, what is that going to look like? They have to like basically break up the monolithic code and then decide what sort of like tiger teams are going to work on different aspects of whatever, you know, software as a service product that they're selling. And then they have to like basically they have to also consider like security and compliance stuff, and they're going to have to think about you know, where all that might be hosted and that sort of thing. So I mean, there's like you have to hire people who essentially are cloud architects and security architects that know what they're doing, and then hopefully you hire people who are really good at keeping track of all of that. Because the other issue is like people can also write a bunch of different, you know, disparate Lambda functions or whatever, and not keep track of what they're doing. You know, very highly achieving experts that seem to know a lot about AWS stuff, but they might not actually they have to keep really good records of what they're doing as they are doing this digital transformation, so that like others can check and make sure that, you know, everything that is moving over effectively, because you also have other concerns like shadow IT concerns to think about. Mm-hmm. So that there's a lot of challenges, and all of that can theoretically cost a lot of money. So, but then hopefully at the end it's worth it, because then you can sell your SaaS product and it's easier for customers to just adopt and easily interact with your product.
Okay. Does somebody want to comment further on the adoption cost?
Or... Yeah, I just want to add that you know, with all the cloud providers, they have this framework on how you want to move to cloud, right? Which also could be applied here. Like, you know, you want to lift and shift, or you want to, you know, adopt and transform, that kind of stuff. And with serverless, you cannot really lift and shift, right? You cannot really put your server software just in a serverless function or something like that. So you need to do some kind of transformation, change your code, basically. And also you need to make sure, you know, you're now running an internet, not in a data center. So you need to be secure. This is what, you know, Melissa was talking about, hiring right people who can make it secure. And yeah, you know, just to get all the benefits of cost effectiveness and paying for what you use and that kind of stuff. So yeah, definitely cost of adoption, it takes some time, because you just cannot run just plain server software on a serverless, you know, like a Lambda or GCP function or something like that. So you need to change it. And so usually, you know, new projects, new software goes first to these systems. And then they're trying to, you know, rebuild old stuff, like what's important. So this is the way it usually goes. It takes time, I think.
Okay, Leonardo, is your internet back? You want to comment?
Am I audible? You keep freezing
Yes,
through me, so I don't know what's up. I got my kids here, so I think it's PlayStation messing up my connection. But that's the way that I keep them close. So that's the reason they're not here. So, anyways, I think the other aspect to cost of adoption, other than what you guys have spoken, that I agree with, is I think sometimes the cost of adoption happens over time. And what I mean by that is, I think if you don't have a clear vision as to how your solution is going to scale over time, and you basically are starting to build stuff ad hoc without clear visibility into cost, sometimes you realize the cost of adoption and it's a little bit too late. So I think it's very important for organizations that are starting to adopt serverless to proper coach their developers as to how to properly identify and project cost over time, so that even if the cost of adoption was manageable during migration, organizations don't come and realize the operational runtime cost of adoption over time when it becomes complex to solve, right? Because there's, I think, one challenge to adopting serverless is also that sometimes developers are, and this is part of that kind of two-sided sword of developer velocity, right? They can go so fast and things just scale magically to infinite proportions that sometimes the visibility of kind of like solid engineering practices, efficient engineering practices gets diluted, right? And people are more focused on going fast and building scalable, performing solutions. And that can cost organizations over time. So again, I think leadership in adopting, kind of the paradigms of adoption are critical to avoid that type of challenge as the organization matures.
Yeah, very, very interesting indeed. And we are transitioning, from what you all said, I believe, we are transitioning to maybe something a little bit more structured on the topic SKILup. I like to end, we have 20 minutes, it's okay, to end with some advices, some best practices. So we probably can classify the best practices we would like to talk about. One of them is obviously the security, because we all know that serverless comes with some security. I don't want to say concerns, but focus. So what would be your best practices, your advice in terms of security for serverless?
I can take this one, I guess, a little.
Lisa?
I've been starting these. So I had mentioned some stuff about shadow IT, and I work in an observability and security product company. So like that's a thing that we help people do. But even if you're not using our stuff, you could use someone else's stuff. It's like I've heard that basically from a lot of customers, the biggest issues that they have actually with like digital transformation and getting things, into a software as a service format, are typically around things like keeping personally identifiable information safe, having things in different backends, going through all the compliance things. There's a lot of things, unknowns essentially. And then as people are kind of working through moving things over, breaking up their architecture, that sort of thing, I would say there's a few best practices with serverless. One is potentially taking on multi-cloud. Obviously, if you're an enterprise, I would highly recommend that, because again, you want to think about disaster recovery, and you want to think about, you definitely want to think about having backups for things. I think that's part of the digital transformation journey in general, though. There's also things like, being able to actually track things that you're doing with, obviously logging and analytics, using SLOs and SLIs, looking at the important KPIs and metrics from an SRE standpoint. And there's that just kind of helps with like overall hygiene. But I think from a security standpoint, you also have to think about, all of the different attack vectors that can essentially happen. I mean, Kubernetes has a lot of security features. I think I covered that in a different SKILup day. But basically, you have to also consider potentially different attack vectors coming into the cloud. And so it's good to have like a good observability solution that can actually do things like be able to have sort of a view of like what is happening with all of your individual pods and all of your individual containers, and essentially like what is actually happening with all these different services. Are things down? Are there issues like an kill? It's a really common one, out of memory exception. Having a good like purple team practice of observe, orient, defense, act, where you can actually work between security and observability groups together. So all of that is good. All of those are really good best practices overall. Anyone else?
I'll go next, because I think one huge piece of advice that I'd give teams that are looking to adopt serverless, whether services or frameworks or architectures, is I think you have to start with a solid foundation around cloud native architectural principles, right? If you're not familiar with 12-factor applications, if you're not familiar with how to create an architecture where state is abstracted, or stateless ideally, you're not using proper versioning practices. You don't still have kind of like promotion across different stages. Your maturity around as code, or everything as code, right? You're using interest code. I think you need to start, like, you cannot overlook those foundations. I think that's critical. The other thing is, to serverless, is I think once you adopt the serverless architecture, and Melissa being from Sumo can attest to this, right? Instrumentation becomes critical, right? If you look at, because now you've got little workloads that are spinning up and down, that are ephemeral, that are running across multiple services, and requests, the actual activity that a user that delivers something to a user is being distributed across different services, and the actual value that you're delivering is the combination of multiple services working in orchestration. Just as when things go wrong, the failure modes are combinatorially explosive, could be, right? Because of the complexity of all these different services interacting with one another. Instrumentation and observability are critical. And I think these are foundations, cloud native foundations, observability foundations, that will be indispensable to a successful production and enterprise scale deployment of a serverless architecture, and will also assist in understanding security, right? Like being able to understand the state of your solution at any point in time from its outputs, observable, is critical. What do you think, Vyacheslav?
Yeah, I think you should consider this serverless architecture and approach from security standpoint as any cloud system you would approach, like where your data is, right? At rest, in transit, how do you secure that? Who can do what, like your role-based access controls, that kind of stuff, access to your function. Since it is a mostly code-focused system, right? So you should be more aware what's going on with your code. Just make sure you don't introduce any vulnerabilities as part of your code. Just add additional checks, just to make sure no credentials committed, that kind of stuff. Also, like specifically for this one, maybe as a security measure, just time out your functions. They're running. You're paying for time that they're running. Like enabling such things on an organizational level can save you a lot of money. Yeah, I think just overall best practice, and also it's a system in the internet, right? Who can access it from a network perspective? You should also consider. I think this is the main best practices I would like to mention.
Yeah, very very good input. This is what I like in that kind of discussion, to have things that the attendees can bring home and brainstorm a little bit on what are the best practices and how I can apply in my company and in my implementation. There is something still on the best practices that I like to talk about. This is one of my sweet spots. It's logging, analytics, information, processing data. How important is it when you go serverless? And maybe if you want to comment, how did it evolve with serverless?
So I guess I can get into logging and monitoring and things like that. So regardless of what people are using for serverless architecture to actually like deploy, could be Kubernetes, could be Docker, could be whatever within different cloud service providers, AKS, EKS, whatever. I would say, logging and monitoring is very important. How it evolved, The tools that people are using over time have evolved. I think people obviously started out doing like VMs, and then they eventually went to a point where they were doing, I guess, the people were using things like OpenShift and stuff. I think they still are, but primarily because I think to do deployments, like there were a lot of unknown unknowns, and I think that there's a lot of folks who out there have already built some kind of solution to kind of help with that. But you still, on top of everything else, you still need to use essentially, you still need to know things like what the GeoIP location is of something in case there's like impossible travel. You still need to be able to look at your logs in order to determine, okay, was there maybe an insight that came up from a security insight perspective that you need to actually address. There's also like machine learning stuff that's out there now that people are using for managing those insights and sort of reducing the load on SREs and security teams with respect to like getting too many alerts. So you also have to be able to hone in on which alerts matter and which ones don't. It's a whole different skill set, a whole new skill set. So that does present a lot of different challenges. But I would say, yeah, it's pretty instrumental to knowing when something goes wrong and what it might be, and being able to sort of diagnose things. In the handouts, I put like an ebook on navigating Kubernetes monitoring. If people are ever interested in that, I'll send a link in the chat as well. Mm-hmm. There's no paywall or anything. So.
Okay, thank you, Melissa. Any comment on that, Yashasrao?
Yeah, I think just in general, it is a little bit different system, and you need to consider different metrics here from observability standpoint, right? And there is a learning curve here, and there are a lot of best practices. You can find a lot of the documentation available, I think. And I think if you have like a managed vendor, like a Sumo, for example, or Datadog, that kind of stuff, Splunk, they can help you with some maybe frameworks available for just it's like a standard set of metrics that they usually consider when trying to observe serverless system. So I would start with this, and just navigate your way through alerts, making sure that you understand what's important to you, like from your business logic standpoint. But it's definitely a different approach, different access points. Some stuff could be related to any other cloud systems, but in general, you need to find your own way to do things, because it depends on what code you are running there. This is crucial from observability standpoint, from my perspective. Leonardo.
Yeah, I think so. Recently, the DevOps Institute released the AIOps Foundation certification. I was the lead author to that certification, so it was kind of an interesting exercise to kind of like document key knowledge around AIOps. And I think for serverless, one interesting aspect that I abstract away is that I think you need to think about observable data just as you would deal with any sort of big data, right? You want it centralized. You want as much of it as you can, but too much is a problem as well. So you want to make sure that it is clean, that you're consolidating data from that which you can instrument and that which has been instrumented for you, right? So all these different systems, whether it's GKE, AKS, or AKS, et cetera, right? They're basically instrumented for you. They're already producing all sorts of observable data that you can leverage. You should be instrumenting the components that you manage on your own and having all that data in a single place, namely in a way that you can cross-reference, that you can correlate, and that you can eventually use to feed algorithms that will help with the stuff that Melissa was talking about, right? Feed algorithms that will help with signal-to-noise ratio, right? How much noise is there in your alerting system, really, right? To help you kind of dig into potential failure modes that you're just not picking up on your own, right? So instrumentation is critical, consolidating data is critical for an observable system. And I think metadata is something that you really need to properly design. Identify everything, right? Identify requests as they go through. And again, kind of going back to my previous comment of make sure that you have your cloud native foundation solid. Ideally, you have gone beyond just logs, right? Ideally, you now are basically tracking metrics in your own instrumentation, as well as building your own metrics from instrumentation that is coming from telemetry that is coming from managed services or your serverless infrastructure, right? And you really need to start thinking about traces to understand how things are progressing through a complex system of interconnected components, right? So getting all that in a single place, having solid metadata with a schema that is consistent across all your services. And this is also important when you have multiple teams building, say, functions as a service, right? Ensuring that they're all following a consistent instrumentation schema, not just logging anymore, but that the metadata that they're enriching their observable data with is consistent and can be used for effective query, for identifying what's happening in your system, right? And this is critical of an observable system, right? The whole idea here is you are looking to identify unknown unknowns, as Melissa points it out, right? And you're looking to identify those through outputs of that system. So the way that you query those
We may have lost Leonardo.
is key to having a legible system.
But he doesn't know it.
You lost me? You lost me?
For the last 15 seconds.
Yeah, but we got most of it. Like we heard the logs, metrics, traces are all important and stuff. We hear you now.
No, we can hear you.
Am I back?
Yeah, you're
Yes,
back.
You're back.
All right, well, keep going. That was the universe saying me, shut up. Let somebody else talk.
we had most of your talk, Leonardo. So the importance of the logs and the metrics, that is something that can help transition and have a better control on the serverless architecture.
Yeah,
absolutely. I try to sum up on a very high level, but Melissa,
I wanted to say I agree with Leonardo that you definitely want to have something that takes in like logs, metrics, traces all together. I just say it all drills down into logs only because I mean essentially metrics are just logs on given different time series data, and so you want to add cardinality to that so that you have like the tiniest time scale. So you can see logging across the tiniest time period. So I think of that as like metrics are like the watch or the stopwatch of logging. And then you have traces, which just essentially are logs that have like a span ID and a trace ID, and they can show you like where your issue is within your infrastructure. And I think like you definitely want to do them all together. There's this great project now that people are doing, OpenTelemetry, that's like combining all of the different collectors and collector management and making it easier for people to actually monitor and observe using a standard. So all of that is very good for serverless architecture.
Okay, thank you very much, Melissa.
Oh, and a quick, am I audible? Just a quick note for folks on the audience. I learned, now that you mentioned OpenTelemetry, and now that everybody's kind of raving about Gen AI and large language models and whatnot, there's a new project called OpenLLMetry, which is kind of like applying the OpenTelemetry stuff to the world of large language models, which is really interesting just for people that are curious to dig around.
Yeah.
Okay.
It's pretty cool. Like I don't want to rat hole on that, but yes, that is also very cool. Having natural language processing and large language models for queries, right? To make querying easier, natural language queries and such.
Okay, and it's OpenLLMetry, Leonardo. Yeah, I got it correct. Okay. So thank you very much. We have to wrap up now. We covered, I mean, the things in a way I like. We try to define serverless. We try to see the benefits, the challenges, and the advice and the best practices. So thank you very much, audience, for joining today. A very big thanks to you, panelists. So thank you, Melissa, and long life to Clicky Keyboards. Thank you, Vyacheslav, and we will definitely time out our functions. We will not forget. Thank you, Leonardo, and we will leave you join your kids on the PlayStation on the other room to jump into the game. Thank you very much, and see you soon in the SKILup sessions. Goodbye.
Bye bye.
Thanks, everybody.
Thanks.